So what is it that gives a linear relationship its straight line pattern? It is the ratio of change when we compare the change in the y values compared to the change in the x values. If that ratio of change is constant, our line will give us a straight line pattern. And again, it's really important to understand it is not the x and the y coordinates. It is a change in the x and y coordinates that give us this linear pattern. Okay? So here we have a direct relationship, okay, where if we take a look at this proportional change, okay, and again, this is important to recognize now, although the table gives us a direct proportion, it's in proportion, it is because it's a direct proportion that starts at 0, 0. Okay, now what we really want to be looking at though is the ratio of change. And we find the ratio of change on the outside, although it shows up the same here, okay, because we are starting at 0, 0, but we find the ratio of change here. So we have plus 1, okay, and on the y change we have plus 2.2. Okay, if I do plus, in this case, let's make a bigger jump, plus 4. We see a big jump here of plus 8.8. And notice that the ratio of change is going to be $2.20 for every mango. Okay, so 8.80 to 4 reduces to $2.20 per mango. So this is our linear relationship. Okay, when we see this constant ratio of change, we are talking about a straight line pattern. So when I graph these points, if I put my x-axis here, 1, 2, 3 mangoes, 4 mangoes, 5 mangoes here, and we'll make this 1, 2, 3, 4, $5 here, okay, and that's going to be $10 here. We're going to go a little bit over that, but 0, 0, 1, and 2.2, 2 and 4.4, somewhere around there, 3 or 5 and $11, somewhere around there. Notice that when I plot those points, I get the straight line relationship, okay, that gives me the proportional relationship. So this constant proportion that we find, okay, this run compared to the rise, okay, or the change in x compared to the change in y, so the change in y here, if I look at it from $2 to $5, the change in y is going to be, looks like it's $6.60. Okay, and the change in the number of mangoes, the change in the number of mangoes, which is change in x, is going to be plus 3 mangoes. And we can see that the ratio of change is going to be $2.20 for every mango. Okay, so this constant proportion, as long as it stays constant in the table or on the graph like this, we're going to get this straight line pattern, and this is what describes the linear relationship. So in this case here, the change in y over the change in x, now I can use any change, and I'm going to reduce it to a unit rate. So I'm going to just use this $8.80 that I found here for every 4 mangoes. And it's really important to keep track of your units here. Okay, and this is going to be equal to $2.20 for 1 mango. This is going to be our unit rate, and we find our unit rates by dividing. So does it matter if I compare these points far apart or if I compare the points that are closer together? Okay, these ones here. Okay, the ratio of change is still the same. So here is going to be 1 to 2.2. Okay, and that ratio of change, although the actual changes are different, the ratio of change stays the same. So does it matter if we compare ratio of change points far apart or close together? No. Okay, the simple answer to that is no. And a couple reasons why. We can say the ratio of change stays the same. Okay, we could also see that in the slope, we're using the slope triangle, and we can alternatively say the slope triangle is in the same proportion for large or small triangle. It doesn't matter. Okay, because they are similar triangles. So then in the end, what is the relationship? The equation that describes this relationship, remember that we have these tables, we have these graphs, we also have a calculation. Well, we could say that the cost is going to be equal to $2.20 per mango times the number of mangoes. Okay, and if we want to write this as an xy equation, it's going to be y equals 2.2x. And if we want a starting point, this is a direct proportion, so we're going to start it at 0.